There are around 150 million monthly active users who uses Discord. Every hour, millions of messages are created and collectively they have trillions of messages. How is Discord engineering handling this massive amount of data? With such an amount of data, it is really necessary to have an operational system without any downtime. Discord started its journey with MongoDB, the very own NoSQL database we all started with. Later, they switched to the Cassandra because they needed a scalable, fault-tolerant and low-effort way to maintain their large amount of data. Unfortunately for Discord, Cassandra was no longer an option because it was experiencing serious performance issues that required increasing amounts of effort just to maintain it, not improving it. In 2017, 10 million users were using Discord. By the end of 2024, there were around 150 million Discord users. That's a 15x growth, and their Cassandra cluster couldn't handle the load. In 2017, around 12 Cassandra nodes were used for storing billions of messages. By the beginning of 2022, Discord had around 177 nodes with trillions of messages. The Discord engineering team was disappointed because it required a lot of work, especially with the frequent database issues that needed urgent attention from their team. They also couldn't predict the performance problem, and the cost of doing them forced them to reduce the unnecessary maintenance. First of all, what was the issue? Here is what a message looks like in a Discord database. Messages on Discord are organized based on the channel they are sent through and grouped within a fixed time period known as buckets. This structure enables Cassandra to efficiently store and replicate messages for each channel and bucket across these servers. However, this setup introduced complications for mainly two types of Discord users. On one hand, the small servers that were sending only a few messages. On the other hand, large servers such as Minecraft, Midjourney, where messages are sent almost continuously. They also face a set of challenges. In Cassandra, writing data is really simpler and less costly than reading it. When a data is written, it is first saved to a log and then to a temporary memory area before they are stored to a disk. Reading data, however, is more complex because it involves checking both the temporary memory as well as the several disk files, making it a heavier task. When many users try to access the same data at the same time, it can really overload parts of the system, creating what's known as a hot partition. This issue can slow down the entire database, especially if one particular area gets too much traffic and struggles to keep up. This slowdown affects not just a busy area but can also delay other operations in the system. Since Cassandra uses a method where most members must agree on read or write, any delay in one part can cause a delay across the board. However, keeping the systems running smoothly requires regular maintenance tasks like combating data files for faster access. But when the system is overwhelmed, it falls behind on these tasks too, leading to further delays and making data access even slower. So what's the solution? Just ask a 5-year-old child, what will he do? He will just pick a new thing, right? Similarly, Discord has a secret crush on another database, Scylla DB. Scylla DB is another Cassandra-compatible database that is written in C++. Discord likes Scylla DB because it promises to work faster and fix things quickly. It is built in a special way that makes sure that each part does its job well, like giving each core its own special piece to work on. Scylla DB, unlike Cassandra, doesn't have a garbage collector because it is made with C++ instead of Java. The team had a lot of trouble with Cassandra's garbage collector, causing delays and even making servers crash, needing someone to fix them manually. These problems created a lot of extra work for the team and caused many issues with sending messages smoothly. By 2020, they migrated almost all their data to Scylla DB except for one thing, Cassandra messages. To start with, it's really a big cluster with trillions of messages and nearly 200 nodes. Any migration was going to be a very big job. They were all suspicious because simply replacing the database wouldn't magically solve all the problems. Even with Scylla DB, they knew that hot partitions could be still an issue. So they decided to improve their systems upstream of databases to help shield and enhance database performance. They faced challenges with Cassandras when too many users access the same data simultaneously, causing delays that got worse over time. To tackle this, they introduce an intermediary service called data services positioned between the main application interface and the database clusters. They choose Rust to develop these services because of its combination of speed and safety, especially for handling multiple tasks at once. Rust is known for its ability to facilitate safe and efficient execution of concurrent operations and important features for managing heavy users. For example, if multiple users request the same piece of data, service queries the database once and distribute the result to all the requesters, effectively reducing the load. Moreover, they implemented a system to ensure that requests related to the same topic are directed to the same service instance. This approach further reduced the pressure on the database. While these adjustments have mitigated some of the issues, challenges such as delays due to hot partitions in their Cassandra system persisted, although less frequently. These strategic improvements have given them additional time to prepare and transition to a superior database system with Scylla DB, aiming for a smooth migration process. The last step is the big migration. They need to move trillions of messages while 140 million users are actively using the platform. It's like relocating the entire population of India to an island without anyone noticing. Here is how they plan to do it. Boot a Scylla DB cluster, migrate new data during a cutover time, migrate the old data behind it. Now all the data is added to both Cassandra and Scylla DB. However, it will take them 3 months to complete the migration. Nobody is going to wait that long, so they built a new migration tool. They completely rewrote their migration tool in Rust. Typical developers. It only took 9 days to do this, migrating messages at a speed up to 3.2 million messages per second. Several months after transitioning their messages database to Scylla DB, in May 2022, the team has observed significant improvements. The new setup had led a quieter and more manageable operation without the emergency interventions that were previously common. They have reduced their infrastructure from 177 Cassandra nodes to just 72 Scylla DB nodes, with each Scylla DB node boasting 9 TB of disk space, more than double the average capacity of Cassandra nodes. Performance metrics have seen a notable enhancement as well. The latencies of fetching historical messages have dropped from a range of 40 to 125 milliseconds to a consistent 15 milliseconds. And the message insertion time have improved from a spread of 5 to 70 milliseconds to a steady 5 milliseconds. These advancements have not only stabilized their system but have also opened an opportunity for a new product feature thanks to the increased reliability of the messages database. An interesting thing happened due to these upgrades to highlight the system's robustness during the 2022 World Cup. The team observed real-time spike in message volume correlating with match events such as goals scored, which they monitored. This unique scenario also provided a creative excuse to watch the games during the meetings, framing it as a proactive system monitoring. The World Cup final between Argentina and France was really noticeable. The team was able to track the game's progression through the spikes in the messaging dust corresponding to key movements and goals. Despite having a global surge in messages during these intense match movements, Discord's system powered by the Rust-based services and Scylla DB remained stable and efficient. That's how they scaled their system to handle trillions of data. Just like that. Now you go and start building your stuff that will reach millions of people. And can I also get 1,000 million for this?